Hi guys, this is Jose with another Python video and welcome back. In this video, we're going to learn how to recreate the famous snake game using Python and Tkinter. So that's just a built-in library within Python that allows us to create graphical user interfaces. And amongst the elements that it allows us to create, there is a canvas element in which we can put anything we like. So in that canvas, we're going to put some images and we're going to make them move around to recreate the snake game. Talking about images, all the images that we'll need for this game are provided. The link is in the description below. So when we do need them, just download them below and you'll be fine. Alongside with the images, we've also provided the final code in case you want to check it out. But I do recommend that you follow along with the video, code along with me, give it a go, and then you check out the code at the end. Alright, so let's get started. We're going to begin by creating our main application. And in that application, we're going to put this canvas. So in order to create an application with Tkinter, the first thing we have to do is we have to import Tkinter as tk. Importing it as tk, which is an import alias, is totally optional, but it just means that we can use Tkinter with a little bit fewer characters to type, so that's always helpful. So what we're going to do is we're going to create our application window. And the way we do that is we create a variable and we assign it to tk, which is this import.tk with a capital T. That's going to create our main application window. And if you want to run your application, you do root.mainLoop. And that starts up the application. So I'm going to save that and press play, and then you get your Tkinter window. Notice that this window does not have a canvas. So we're going to be setting the dimensions of the window and the canvas all together. The first thing to do though is to give it a title so that the application window has a name and it looks a little bit nicer. And then we're going to make it non-resizable by passing false and false to the root.resizable method. That's going to set it unresizable in the X and Y axis. Then we're going to create our canvas. And normally you can just do something like canvas equal tk.canvas and put it into the window like that. But because we're going to be putting so much stuff into the canvas and also a lot of game logic into our canvas, we're actually going to inherit from canvas and create our own class. And we're going to do that just up here. We're going to do a class snake, and that's going to inherit from tk.canvas. And what that means is that our snake class is now a canvas. So whenever we set any properties or access any methods of the snake class, we're going to access them in the canvas unless we override them in our own class. We're going to start by defining an init method. And in here, we're going to call the superclasses init method, which, as you know, is the canvas. So any properties we pass to this init method, we could pass to tk-canvas if we defined it down here. And some of the properties that a canvas accepts are things like width, height, a background color, which we're going to go for black, and also a highlight thickness, which we're going to set to 0. So the width and height, I'm sure you have no problem with. The background is going to be the color of the entire canvas, and canvases by default have a border around them, and we don't want that, so that's why we're setting the highlight thickness to 0. By default, I think it's 1, and it shows up as a white border. So now that we've got our canvas class, we have to create it and put it into our window. And how we're going to do that is we're going to create something called board. For example, you can call this variable whatever you want, and that is going to be an instance of our snake class. Remember that our snake class for now is just a canvas, and when we create it, we're calling the canvas's constructor and setting some properties. Then we have to put it into the window itself, and we do that with the pack method. The pack algorithm is one of Tkinter's ways of putting elements into another element. In this case, we're putting the canvas into the window. And if you want to learn more about pack, we've got a blog post that should appear in a wee card on the video, or also it's linked in the description below. So now that we've got this, when we press play, you see that the window has gotten a little bit larger, and now it is black because we've got our canvas created. Next up, let's move on to loading the assets, which is the images that we've got available here. Again, these images are linked in the description of this video, so if you want to download these, just go ahead and click on that. We've got a snake, which will make up the body of the snake, and a food, which will make up the food elements. So if you've not played Snake before, the snake just is comprised of a bunch of squares that move around the screen, and when the head of the snake interacts with the food, then it eats it and the snake grows by 1 square. So we're going to start off by loading the assets, and how we're going to do that is here in the init method, we're going to do self.load assets, And this method doesn't exist yet, so we're going to create it. And the load assets method is just going to take those images and import them and store them locally. Before we're able to load any assets, though, we have to install a library, which is the pillow library. How I recommend you do that is you go to your editor of choice. Here I'm using Visual Studio Code, by the way, I forgot to mention, and create a new virtual environment, and in there install the pillow library. If you're using PyCharm and you created a new project in PyCharm, you already have a virtual environment for your project, most likely, so you can just go to your preferences and install pillow there. What I'm going to do is just pipenv install pillow in my terminal, and that's going to create a new virtual environment and is going to install the pillow library in it. So once that's done, I will have the capability of importing images into my project. Alright, so we finished installing the pillow library. We can close that, and we're going to go ahead and import from pill. We're going to import image and image TK. So image is going to allow us to load up an image, and image TK is going to allow us to place it on a Tkinter widget. So inside the load assets method, we're going to try, and we're going to put this code inside the try block because just in case the assets don't exist. So if we forget to add them or put them in the correct folder or something like that, then this will fail. And we're going to do self.snake body image is going to be image.open, and it's going to be the assets snake.png image. And also we're going to do self.snake body, and that's going to be image tk.photo image on self.snake body image. What this does is it opens up the assets snake.png image, so the assets folder and then snake.png, and then it creates a photo image from that using the image tk class and puts it into self.snake body. We can do the same with the food image, just like that. And finally, we're going to accept an IO error as error, and we're going to just print it out and do root.destroy. Root.destroy is just going to close up our window, so that's something that we can do if we encounter an error that we cannot recover from. There we go, we've got our assets loaded. Now we can place them into the window, so that's our next step. Before continuing, let me just take a couple of seconds of your time to tell you about our new graphical user interface development course that uses Python and Tkinter and sort of covers all your bases, from creating games to business tools, how to draw graphs on the screen, interact with APIs, and we'll even create a small chat application as well. So if you want to learn more about creating desktop apps using Python, please check out the course. It's linked down in the description below, and it would really help us out. So thank you guys. Let's continue with the video. We're going to start off laying assets into the window by defining where the snake is going to start. How we're going to do that is we're going to do self.snake positions, and we're going to define a list of tuples, where each tuple is going to contain the x and y coordinates of one piece of the snake's body. Remember, the snake's body is made up of multiple squares. So here we're going to start with 100, 100, and then another tuple with 80 and 100, and one more with 60 and 100. Notice that each of the elements in the body is 20 pixels wide, so that's why we're separating the snake body positions by 20 pixels. Then underneath the load asset, so after we load the assets, we're going to do self.create objects, and that's another method that we have to create as well. And what that's going to do is actually going to place the assets into the window. So we'll do create objects, just like that. Remember to put in self there. And in here, we're going to do for each of the positions in the snake position. So we'll do for X position and Y position in self.snake positions. Then we're going to create the images. So we'll do self.create image. And this create image is actually a method that exists within the canvas. So when we do self.create image, Python is going to look at the methods that we have defined in the snake. It's not going to find create image amongst these methods, so it's going to go to the parent class. And there it's going to find self.create image. And what that's going to do is it's going to create the image asset that we give it and place it at the location that we give it. So create image is going to take the X position and the Y position, and then it's also going to take an image parameter that is going to be the snake body, And finally, it can optionally take in a tag. The tag is then going to allow us to retrieve images from the canvas or find them in the canvas. And that's going to be really handy. You'll see how in just a moment. So we're going to do self.create image with X position and Y position. The image we want to create is the snake body image that we loaded earlier. And we're going to tag all these images that we're creating with the tag snake. Notice that this is going to create 3 instances of the image. One in position 100, 100, one in position 80, 100, and one in position 60, 100. So if we save that and press play, you can see that our snake is now starting to appear in our canvas. We've got our 3 images placed in our positions there. Of course, no snake game is complete without the food, so that's our next step. We're going to place the food into our application here. We're going to do self.food position under snake position, and we're going to start off with some position like 200, 100, and in the create objects method, we're also going to place the food. So we'll do self.create image, and in here, we're going to pass self.food position 0, self.food position 1, the image is going to be self.food, and we're going to tag that with food. All right, so here we're creating the other image. We're going to save that and run it, and you'll see that we've got our food just there. Now, something interesting about this self.food position 0 and self.food position 1 is that because we're passing all the elements of self.food position, and the first element we're passing is element 0, and the second element we're passing is element 1, we can actually use destructuring to pass this in a little bit of a simpler and shorter way rather than doing this manually. So instead of that, we can take away all of that and just pass in self.food position, but put an asterisk in front, and that's going to destructure the tuple and pass it a separate argument. And if you want to learn more about destructuring in Python, we've also got a blog post that's linked in the description of the video below and also on a card that should be appearing right about now. Alright, so that just works in exactly the same way. Before we start with moving the snake, we're going to look at how to display the current score of the player in this canvas. So we'll start by defining self.score to be 0, and then in the create objects here we're gonna self.create text, and that is going to allow us to create any sort of text we want in the place we want it to, and we're gonna put it in something like 4512 just at the top of the screen, and the text is going to be score self.score. All right, we're going to tag that with score, and we can also define a fill property, which is the color of the text, and we can also define a font. Fonts, usually in Tkinter, are also defined as tuples, and the first value is the name of the font. We're going to use TK default font because that uses the default system font, and the size is going to be something like 14 for now. So if we press play with that, you get the score equals 0 there at the top. Next up, we're also going to define some boundaries for our game so that players know when they're about to crash. So just down here, we're going to do self.createRectangle, and we're going to pass in the coordinates of the rectangle, so where it's going to start and where it's going to end, and then Tkinter is going to draw the lines between those 2 points. So we're going to do something like 727, 593, and 613, and the outline is going to be something like 525D69, which is going to be a sort of light gray. So if we do that, you've got your rectangle now. So if you get too close to that rectangle, indeed, if the snake crashes against it, the game should terminate. And we're going to learn how to do that in just a moment. So the next step is to move the snake. We're going to create another method, moveSnake, that is responsible for moving the snake. And we're going to start off by telling our canvas to move the snake to the right. So we'll start with the head X position and head Y position, and these are going to be the initial snake positions 0. So the starting element, or the first element of our tuple, is the head of the snake, and any other elements are the body of the snake. Notice that this one is more to the right by virtue of having 100 there than these that are more to the left. So really this is sort of reversed of the initial position. This here is the head and that's the body. And what we're doing here is we're taking the first tuple in snake positions, that's the 100, 100, and we are destructuring into 2 variables. Again, this is the destructuring blog post that is linked down below. Once we have the current head position, we can create a new position. So we are going to say new head position is equal to, and we'll start with head X position plus 20 and head Y position. So this defines the position of the head the next tick of our game. And we haven't defined the tick time yet, but we will. To begin with, though, we're going to take this 20 and we're going to extract it into a variable move increment. And I'm making it all uppercase because it's a constant. I'm going to put it here, move increment, and that's going to be 20 there. So now we have the new head position. But of course, if we move the head, we have to move the rest of the body as well to match it. Or what we can do is we can actually move the head or copy the head and then chop off the last element of the tail. So if we copy the head and move it, and then we chop off the last element of the tail, that essentially achieves the same thing. And that's what we're going to do. We're going to do self.snake positions is now going to be the new head position, which is going to be the first element, plus all the other positions except the last one. And what we'll do is we'll do self.snake positions except the very last element. And here we're using list slicing to access all of the elements except the last one. And if you want to learn more about list slicing, guess what? We've got a blog post on that. That's also linked in the description below. So what that's going to do is it's going to essentially get the new body of the snake, and it's going to position it at the head and all the other elements except the very last one. However, changing these values, changing the snake positions, isn't actually going to change the canvas images, because the canvas images are sort of static, already drawn on the canvas. We have to tell the canvas to actually translate those images and move them from their current positions to the new positions that we've defined here. Unfortunately, it's not dynamic, it doesn't change by itself, so we have to do that ourselves, but this is where the tagging is going to come in handy, because we're going to do that for each segment and position in zip of self.find with tag of snake and self.snake positions. We're going to do self.chords and we're going to move the segment into the new position. So this is all a little bit complicated, but essentially what we're doing here is we're going to find all the elements that have a tag of snake. So that's all our images that we defined earlier on. And we're also going to get all the positions. Something interesting about these two sets of things is that they are the same length. So we've got the same number of elements with a tag of snake as we do snake positions. So when we zip them, you end up with a tuple that essentially intertwines them. And what that means is you end up with a tuple of the first element with this tag and the first snake position, then another tuple of the second element and the second position, and then another tuple of the third element and the third position. So that's what the zip function does. What that means is then you can get each pair of tagged element and position using this deconstruction method here, and then you can change the position of that image into this new position using self.chords. So this is the little bit more complicated code that we're going to see here. Self.chords is a method within the canvas that will tell you the current coordinates of an element if you call it like that, or it will move that element to the new position if you call it with a set of coordinates. So that's what that's going to do. Now, we're not calling this method anywhere, so we're going to do that. Down here, we're going to create a new method called perform actions, and in this method we're going to do self.move snake, and then we're going to do self.after, and what this does is it calls a function after a given time. So we'll do after 75 milliseconds we're going to call self.perform actions again. Something really important is that you want to pass in the function name and you do not want to pass in the function call, and that's just so that Tkinter knows that it has to call this function after 75 milliseconds and not the thing that this function returns after 75 milliseconds, which would be none, by the way. So we've got that. Now we also have to call perform actions initially the first time. So we will do up here self.after 75 self.perform actions in the same way. So when we do that and we press play, you can see the snake is migrating away from the screen and then eventually disappears. That's because we haven't told it to stop at any point, so it just keeps adding new head positions and translating the other body positions except the last one, and that makes the new snake positions, and that happens every 75 milliseconds endlessly. Before we look at collision detection, how to make it stop when it reaches the edge, or also how to change direction, we're just going to clean up a little bit. Instead of hard coding 75 here, which is a little bit ugly, we're going to extract this into a set of constants at the top of the code. So we will do the moves per second are going to be 15 initially, and the game speed is going to be 1000 milliseconds integer division or floor division moves per second. That's essentially going to equal to 75 initially, but you're going to be able to change the game speed very easily just by increasing or decreasing the moves per second. Then here we're going to use the game speed instead of the 75s there and there. That means that if you press play at the normal speed, you end up with that speed, but if you want to increase it to, say, 25, then it is much faster. And I almost couldn't bring the window into view there. So that's the constants there. Now we can move on and start checking for collisions. So we're going to, of course, create a new method that is going to be check collisions. And in this method, we're going to start off by getting the current head of the snake, just as we did up here. So we're going to copy that and paste it in there. We're getting the head because we want to make sure that the head hasn't collided with any of the borders of our canvas. So we'll say that we want to return whether the head X position is in 0 or 600. Remember that our canvas is 600 pixels wide. So if the head X is one of these two values, either 0 or 600, it means that the head has collided with the edge. Or the head Y position is in 20 or 620, and we want 20 and 620 because the canvas is 620 pixels high, but it doesn't go to the very top, so it doesn't start at 0 because we've got our text, our score text there, so we want to limit it to 20. Now, this will check against boundaries, but it won't actually check that the snake hasn't eaten itself. So what we are going to do is add one last check here, and we'll say head X position, head Y position, so the tuple of X and Y is in self.snake positions, except the first one. So what this is doing is checking whether the head is one of the body elements. And if it is, that means that the snake has collided onto itself, and that's another way that you can lose in the snake game. So this method here, check collisions, is going to return true if any of this is true. What that means is if we collide on the x-axis against the sides, or along the y-axis and top and bottom, or we eat ourselves, then we're going to return true. And what we want to do in perform actions is we want to say if self.check collisions, then we want to return. What that means is when we return, we no longer call self.after, which means that we're not going to perform actions again. When we return here, the game will stop. And as you can see, if I press play, as soon as we reach the edge there, we end the game. Next up, we're going to look at moving the snake. By default, we're starting up moving towards the right. So we're going to go up to the top to our init method, and we're going to do self.direction is right. Then what we're going to do is we're going to get all of the key presses, and we're going to run a function when the user presses a key. Within that function, then we're going to look at the arrow keys and see if we have to change direction or not. So what we'll do is we'll say self.bindAll, and it's going to be less than key greater than. This is a Tkinter string. That means any key that has been pressed in the keyboard. And the second argument to bind all is a function that we want to run. So we're going to create a method called onKeyPress. We're going to pass it to bind all. Whenever a key is pressed, we're going to run this method. So we have to go down here and create the onKeyPress method. And what this method is going to do is it's going to start off by getting the new direction. So we're going to say new direction is e.keySym for key symbol. And the e, by the way, is going to be another parameter to this method. Whenever Tkinter calls a function bound to any key, then it also gives us an event. The event contains some information about which key was pressed, amongst other things. So that's what the keySym property means. It's going to give us the symbol associated with this event, so that we can say self.direction is equal to new direction. Okay, we're going to add a little bit more there in just a moment, but first we're going to actually make the snake listen to that, because at the moment the new head position that we're changing to is always increasing in the x direction by move increment. So even if we press an arrow and we change self.direction, that's not going to change unless we make use of self.direction here. So it's going to be really straightforward. All we're going to do is have a bit of a if statement here. If we're going to say if self.direction is equal to left, then we're going to set the new head position to be the head x minus the move increment. And we're going to do something similar for every other direction. Alright, so I've gone ahead and completed this if statement. If the direction is left, then we are moving to the head x minus the move increment and the head y. If it's right, it's the head x plus the move increment and the head y. If it's down, it's head x and then head y plus the move increment. And if it's up, it's head x and the head y minus the move increment. So that's how the snake head is going to move depending on self.direction. Now, if we press play, we can now start moving our snake, as you can see. But if I'm going down and I press up, the game terminates because the snake's head has sort of moved up and curled up inside itself and eaten its body from the inside. And that's how we lose. So we want to avoid that. We want to avoid the player from being able to eat themselves just by going in the opposite direction they're currently going. And the way we're going to do that is in the onKeyPress method here, we're just going to prevent the direction from changing if it is the opposite to the direction we're currently going. And so what we're going to do is we're going to say that the all possible directions are up, down, left, and right. And actually we want to do this because at the moment self.direction could be set to something other than these strings if we press, for example, the A key. And so by getting the directions here, we can now say, first of all, that if the new direction is in all directions, then we want to set self.direction to that. So we're only going to set self.direction to one of the arrow keys. But we don't want to check just for that, because as I said, we also want to make sure that we're not changing self.direction if the new direction is the opposite of where we're currently going. So we're going to define opposites, and this is going to be a tuple of sets. Each set is going to contain the two opposites, up and down, and left and right. So now that we have these sets, that means that we can check whether the new direction and self.direction make up one of these opposites. So we'll say if new direction is in all directions and new direction self.direction not in opposites, then we will change self.direction. What this means is here we're creating a new set that contains the new direction. Let's say we're currently going down and we press the up arrow. The new direction would be up and self.direction would be down. So up and down are in opposites. It's right here. So we would not change self.direction. And you might say, well, what if we're going up and we press a down arrow? Then this set here would be down up, not up down. So will it still work? And the answer is yes, because sets don't care about order. They don't have an order. So Python is actually going to like it whether we have up down or down up. So this is a great way to check for membership without having to worry about the order of the elements within it. So this now means that when we save and run, we can move the snake about, and if I press right or up, I'm pressing it right now, by the way, the opposite direction, then we don't die, which is pretty nice. Notice that now I'm eating the food, but nothing's happening. That is the next step. All right, let's go ahead and implement the collision detection with our food. To implement collision detection with the food, we are going to create a new method that is going to be called check food collision. And what this is going to do is it's going to take the current head position of the snake and it's going to check whether it's the same as the food position. So it'll say if self.snake positions 0 is equal to the current food position, that means that we have collided. So all we do is we start off by incrementing the score. So we'll say self.score plus equal 1. And we're going to add a new element to the body of the snake. So we'll say self.snake positions.append, and we're going to append a new position to the snake, which is the last element. So we'll say snake positions -1. What this does is it takes the very last element of the snake positions and it appends it to the snake positions element. This is going to work because immediately after doing that, we're going to move the snake and we're going to remove the last element. You can remember we did that here. But the last element is actually going to be duplicated because we're going to have 2 of them. That means that the last element of the snake is going to be essentially one on top of another. We're going to take one away in the move, but we're going to be left with the other one that we're appending right here. So this is why that's going to work. After appending that to the snake, we have to create the image, because if not, this would not appear until the snake moves. That's going to look a little bit weird, so we're going to create it right here in this method. So we're going to do create image, and it's just going to be the exact same that we had earlier on for creating a single image, like where we created the food. But we're going to create the snake positions -1, which is going to be the very last element. The image is going to be the snake body. And we're also going to tag it with snake. Remember, if we didn't do this, the next tick, the snake would move and the body would grow. So that would look maybe a little bit strange. So immediately, as soon as we eat the food, the snake is going to grow by 1, which is going to look a little bit nicer. Then we're also going to update the score. So we'll do self.find with tag, and we're going to find the score. And we tagged that earlier on when we created the score text. So this is going to find that, and what we can do is self.itemConfigure, and this is another method of the TK Canvas, and that's going to take the score or any element within the canvas, and it allows us to change its properties. So what we're going to change is the text, just to be the same thing, but with the new score. So this just updates it. And again, the tag is still going to be score. Now, we're not calling this method anywhere, so we do have to do that. And the position for this one is quite important. So we're going to do check food collision right there before we move. So if I run this, you can see that I can now move the snake and I can eat this food there. The food doesn't move, which makes it pretty easy. But we're going to look at how to make it move just now. In order to place the food randomly on the screen, we're going to create another method. And that's going to be set new food position. And setting a new food position is actually a little bit harder than it seems, because as our snake grows, as the player gets more points, then it is more and more likely that the new food position, if we just place it randomly, will be under the snake. And that can be a little bit tricky. Imagine you've got a very large snake that takes up a large portion of the screen. The food is under your snake and you don't know where. That can make it actually quite difficult to figure out where you need to move in order to find the new food. So foods have to appear somewhere where the snake is not. So we're going to start with a while loop, and we're going to do while true. So this is going to repeat endlessly until we break out of this loop. And what we're going to do is we're going to generate a new random position for the food. We're going to check whether that's under the snake. And if it's not, then we're going to break out and use that food position. And if it is, then we're just going to generate a new one. So we will generate the X position to be rand int between 1 and 29 times the move increment. And similarly, the Y position to be between 3 and 30. So those are the sort of magic numbers for the dimensions of our screen. The move increment is 20, so this is going to go all the way up to 600, from 60 to 600. This one's going to go all the way from 20 to 580. So those are the dimensions of our screen. Remember that the images are 20 pixels wide, by the way, so 580 means that it's going to go right up to the border, which is 600 pixels. So we've got our two positions. We're going to do food position is equal to X position and Y position. And then we're going to say if food position is not in self.snake positions, then we will return it. And if it is inside snake positions, then we won't return it, and we will just repeat and generate a new one. Now, rand int, we have to import that. So let's go up to the top of the file and do from random import rand int. So this is another built-in module in Python, nothing to install there. It just comes with Python. So now that we have that method, we can go ahead and instead of defining the food position to be 200, 100, we can say self.set new food position. And down here, where we check the food collision, we're going to say that since we've collided, we're going to say self.food_position is self.set new food position. And we're going to do self.chords, the find with tag of food. And that's going to be self.food_position. So if we press play now, you'll see that the food ends up in a random place every time we eat it, which is exactly what we wanted. And also notice how the snake is growing as we go along. This is a difficult one. There we go. I'm good at this game now. Actually, you guys are probably going to be better at this than me. My high score is pretty impressive. I'm going to show you that at the end of the video. I've also got an extra challenge for you guys. So we're going to be implementing a small change to the game towards the end of the video as well. Anyway, so we've got now pretty much our entire game. The next step is going to be to set an end game screen. And just so that when we do collide, if we do collide, we set as we tell the user the final score and sort of game over, you know, and so on. So we're going to do that with, of course, a new method. And that's going to be called end game. And what this is going to do is it's going to do self.delete tk all. And what that's going to do is it's going to call the delete method of self, which is the canvas, and it's going to delete everything within it. Then we're going to do create text. And to this create text, we're just going to put some text in the center of the screen that says game over. Now, how to center text in Tkinter? We do self.winfo width divided by 2 and self.winfo height divided by 2. That is the X and Y position of our text. The text is then going to be game over, you scored self.score. And we have our fill, which is white, and we have our font, which is the TK default font at something like 24 pixels. Okay, so there we've got our end game method. This deletes everything and creates a text. So what we're going to do is here in the perform actions, just before returning, we're going to do self.endGame. That's going to delete everything and then it's going to stop. So let's press play. And here we have it. And then we stop and we call game over. I scored only 1. So this is pretty much our entire game. Now, for that extra challenge that I mentioned a moment ago, we're going to periodically increase the game's speed. I think this is great because otherwise it can get a little bit boring, even though the snake is growing and that makes it increasingly more difficult. If you want an extra bit of challenge, we can also periodically increase the moves per second. Now, moves per second here is a constant. That's why I've put it all in uppercase, but we're going to change it to moves per second, not a constant. Just like that. And then what we're going to do is we're going to go down here and where we check food collisions and we increase the score, we're going to say that if the score is a multiple of 5, we're going to increase the move speed. So we'll say if self.score divided by 5 gives you a remainder of 0, then we're going to do global moves per second plus equal 1. So every time we reach 5 points, and then 10 points, and 15, and so on, we're going to increase the number of moves per second by 1. As well as doing that, we're going to go into the score at the very top, and we're also going to add a speed counter here. Just like that. And down here, where we update the score, we're going to do the same. Now, because this is getting a bit long, I'm just going to split it out into multiple lines so it's a little bit easier to read for you guys. But because we've made the text grow, we've essentially made it larger, we also have to shift it to the right. So what we're going to do is here in the create text, we're going to increase this a little bit. We're going to go to 100 pixels on the X coordinate. So now you can see I'm at 15. And as we approach 5, the speed is going to increase. There we go. Now we're at 16 in speed. And that's just going to keep increasing. So that makes it a little bit more challenging. So yeah, that's how you can create a snake game using Tkinter. It does require thinking about the logic of the game a little bit. But once you know how to place things on the window and how to move them using the chords method, it becomes a little bit easier. So let me know how you guys get on with it, if you can get a higher score than me or not. And of course, if you create any other games or you want to try something else out or you've got any other suggestions, do leave a comment below. We'll be more than happy to try it out. We're thinking about also teaching you how to create a Tetris game, which would be really interesting. So thank you for joining me in this video. I hope you've enjoyed it. Give it a like and subscribe to the channel. Flick the bell as well if you want to receive notifications. And I'll see you in the next video.